Okay, today we're going to talk about direct variation. And you can tell that an equation shows direct variation when it can be put into the following form: y equals ax. Another term you're going to have to know is that a means your constant of variation. And what that does is it tells you how much y is varying from x. So, the way you would read this is y varies directly as x. That's the most common phrase that you'll hear. Another possible one is y is proportional to x. And you'll notice it's very, very similar to our slope-intercept form. Y equals mx plus b. Okay? And actually, your slope is the same exact thing as your constant of variation as long as your b equals 0, or your y-intercept equals 0. So this is important. Every time that we're doing direct variation, the y-intercept will always be 0, okay? So this will not be present. All right, so now what we're going to do is we're going to try, we're going to go ahead and take two equations and we're going to tell whether they show direct variation or not. So remember we said that an equation shows direct variation if it can be put into the following form. All right, so we're going to start first with this equation, and then we're going to go ahead and do this one. All right, so remember we said it has to get into this form, so we're going to do that the same way that we get something into slope-intercept form. We're going to isolate y. So we'll subtract 12x from both sides. So 4y equals negative 12x, and then divide by 4. Therefore, y equals negative 3x. All right, if you look to compare these forms, yes, indeed, this does show direct variation. If we wanted to tell what the constant of variation is, we would say that a equals negative 3. All right, let's go ahead and try this one right here. Again, we want to go ahead and isolate y. All we have to do is add 5x. Therefore, our equation looks like this. Now notice, this does have a y-intercept, okay? This does have a value here. So therefore,